Question number 4. So, which of the following statements regarding the ions formed by S and P block element is false? Right? So, cations are always smaller than neutral atoms. So, for an example, let's take the same period like sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Okay, so let's check. The cations are always smaller than their neutral atoms. So for an example, let's take about sodium plus. So what do you think about sodium plus? Here there were 11 electrons and here there are 10 electrons. But here there are 11 protons. Here still there are 11 protons. So the effective nuclear charge is higher here because one electron is missing now. So there will be higher amount of effective nuclear charge since the number of proton is same. So anyway, when you consider about this one, so this one would have a bigger radius and this one would have a smaller radius than this one because now same number of proton, one electron is missing. So according to that, this statement is correct. And anions are always larger than their neutral atoms. So we will consider the anion chlorine here. So chlorine and Cl minus. So again, you can imagine in this case, same number of proton, but there is an additional electron now, which shields the effective nuclear charge. So it will be a little bit expanding, right? So when you consider about the size here, so here chlorine will be like this, and Cl minus will be little larger than like this. Okay, so similar comparison here, one electron is missing, here one electron is addition. So this is also correct. The size of cations decrease from left to right across a period. So let's take two cations, sodium plus and magnesium 2 plus, which have the same number of electrons, but here also 10 electrons, here also 10 electrons, but here when you compare about the number of protons, here it is 12 protons, but here there is 12 protons, right? So here 11 protons, here 12 protons, in fact. Okay, so when the number of proton increases, you should understand the effective nuclear charge increases. So the size of this magnesium 2 plus get even smaller than sodium. Okay, so this statement is correct, it decreases. And the fourth one, the size of anions increase from. So we will consider again. So there is Cl minus. So we will take another one, sulfur here. Okay. So S2 minus. Now think about here. There is one additional electron here. There is another two additional electrons here. So the shielding character here, okay, is higher. Okay, so when you compare S2 minus and Cl minus, here the shielding character is very high. So there will be a higher radius here than Cl minus. Okay, so when you go from left to right across the period, it is not increasing. Still, you can see when you just compare sulfur and chlorine, it is decreasing. You understand this? So you try to analyze through the same number of electrons, but differentiating the number of protons or either the charge. Now here it was same number of electron, number of protons are different. Now here the number of protons are also different, but number of electrons are same. Okay, so think about that. But here there is a higher charge, so which shields this effective nuclear charge more. So this statement is wrong. Okay. The size of anions formed by elements of the second period are larger than the cations formed by the elements of the third period. So anyway, when you compare like lithium and sodium, let's compare like lithium plus and sodium plus. What do you think? The entire shell is removed, right? So anyway, this is small, this is larger. And when you consider about anions, for an example, F minus and Cl minus, okay, the size of anions formed by the elements of second period are larger. So second period means what? And they're talking about third period to compare with the cations of the third period. So when cation is formed from the third period, it automatically falls to the second period. Why? Because electrons are removed, the entire shell is removed. And anions forming still remains in the same third period. For an example, if fluorine is there, it will take a one electron and it will form F minus. So the electron will be in the same shell. But here when sodium plus removes one electron, it will automatically fall into this second period, like the second period, because entire shell is removed. And when you compare this and this, automatically you need to understand this statement is correct. Because there is a negative charge, there is a positive charge. So this is small, this is larger. So this statement is also correct. Okay. So this is another informative question, I would say. This is theory. So this is informative because you can understand the trend of this cationic and anionic radius across a period as well as across a group. So this is very nice. Okay. So this is some of our discussion of this question.